Well, good afternoon, everybody, and welcome back to another Technolive stream. Hope everybody is keeping well. It's me again this week doing the intro, and I'm joined today by Nia once again. Welcome, Nia.
Hi, thanks for having me back.
No problem. Thank you for coming back once again. So we're just going to start off this week. I'm just going to cover one or two things just briefly before we jump into today's session. In terms of what's going to be happening over the next few weeks. So next week is half term for a lot of you, as I'm sure you're all aware. And that means that, of course, we haven't got any Techno Clubs sessions happening next week. We have, however, still, I believe, got a Technolive session happening. That will be happening on Thursday. So Techno Clubs won't be happening, but you have got the opportunity to sign up if you wish. So if you head over to the Technocamp's website and have a look there at the What's On section, you should be able to find that there's some sign up links there to the Monday, Wednesday, and Friday clubs. So if anybody is interested and wants to sign up to those, feel free to do so. And we'll look forward to seeing you again after half term. In the meantime, however, what we're going to do today is we're going to jump into something slightly different. We're going to be doing some Unity today. Now, Unity is a very, very popular platform that's used for game development. And have you used Unity before, Nia?
I have never used
Never
Unity,
used
so
Unity.
I'm
So
excited to see what it's like.
excellent. Okay, so we're going to be doing basically a bit of a basic introduction to building up a small platform, and we're going to put a moving character on that platform that we're going to program um, using some basic code. Now, a lot of you might be familiar already with text-based programming, so things like Python and that sort of thing. This is a little bit different. We're not going to be using Python today. It's going to be a bit more related to C# than it is to Python. So it's slightly different. It's a bit more wordy in some ways, but we're going to be going through it step by step. And just before we actually get going, I would like to just point out that the code that I'm using today, as well as the this sort of tutorial in a way to Unity that we're going to be doing today, it is some code that was written by one of my that I've had permission to use from one of my academics, one of my lecturers at Bang University, Dr. Hirap Kenneth. So thank you very much, Hird, for allowing me to use your code and this resource in this Technolive session today. But without further ado, I'm going to switch over into Unity. So hopefully you can all see that now. I've already done the basic setup phase where I've launched Unity and created a new 3D platform. Now, some of you may have access and a license to Unity, some of you may not. I have access to Unity via my university login, but some of you might not have access. So apologies if you don't, and Unity is not available or not something that your machine is capable of running at home. But if at some stage you do get access to Unity, this is something that you could look back on and have a bit of a play with and see what you can come up with. So, like I said, what we're going to do is we're going to start by doing a little bit of a basic introduction. I'm not going to go into too much depth on this. Because as you can see, there are multiple different kind of options, multiple different menus and multiple different things that we could potentially look at. So we're going to stick to kind of just the basics today, really. I've got two windows that are, now again, it might look different on your machines, but what I've got are two windows placed next to each other. The one on the left is where I'm actually going to be building my platform, and the one on the right is kind of like my preview. Okay, so this is going to be where I can actually see my game as it's developed. Okay, now running down the left of the screen here are basically going to be all of our kind of like assets, okay, that are going to be within our scene. So this is our scene, and we're going to be placing a series of assets within our scene. So one of the easiest ways, in my opinion, to kind of move around our scene in order to place objects and things is you can sort of swivel and rotate by holding down right click and moving your mouse. You can also zoom in and out using the scroll wheel, or another really useful way if you're using a PC or possibly even a laptop as well is if you hold down the left Alt key, you can actually navigate around using the mouse, okay, which is a lot easier than, and also by holding down the middle mouse button, the scroll wheel, you can navigate around your world a little bit. Okay, so it's quite easy. It's also, if you hold down right click and use the WASD keys, you can see that it's quite easy for me to kind of move around the world. Okay, now we have got, of course, this sun here. This is the light. So our scene is going to contain some kind of light, which is also going to have some shadows. So the direction of the light will indicate where the shadows fall within our scene. Okay, and we've also got the main camera. Now you can see that I have a preview here of what the camera can see, and we can reposition our camera to point at particular parts of the world, or of the scene, sorry, so that we can actually decide, what our game is going to see when it starts. Okay. Now the rest of the things that we're going to go through today, I'm going to talk through as we kind of add various components to our game. But how are you feeling about that so far, Nia? Fairly confident?
Yeah, I think so far so last time I was on, we did Game Fruit, and this is clearly a step up, I think.
It is a bit of a step up. Yeah, it's just a bit.
But yeah, so far I think I understand what's going on. There's sun, there's a camera. I'm on board.
Excellent. Okay, so we're going to start. Off with basically adding some kind of plane. Okay, which is effectively like a platform that we're going to use as a means of basically having our characters rest on, essentially. So that way, when we're actually moving around, there is some kind of world in a way that they're able to use. So what I'm going to do, I'm going to right click on the left of the screen here. You can do it sort of anywhere on the left of the screen where your assets are going to be. And I'm going to right click and I'm going to add a new 3D object. And you can see that there are a list of them, and the one I'm going to choose is plane. Now you'll notice now that I've got a plane that's just appeared here. Okay, this is an object that we can use. Now what I'm going to do with my plane is, at the moment it's looking, I can move it up and down, as you can see. Okay, I can actually move it up and down, and I can move it from side to side. Okay, and it operates, as you can see in the top right here, along the X, Y, and Z axis, which means that we can move around. We can move our plane around and any object in Unity along each one of these axes. Okay. Now, currently, if I wish, I can also rename it to being something that's a bit more appropriate. So I might just decide, like we had a floor layer in Unity last week, I'm going to call this object my floor, okay? Or you could call it ground or anything like that. Now, there are other options along the top of the screen here which will allow us, if we wish, to rotate. And you can see that that changes the rotation value just up here as I do so. Okay, so we can rotate our objects, again, along the X, Y, and Z axis, or we can just move it from left to right and side to side and up and down and things like that. Okay, now it's currently looking a little bit bland because it's just a weird kind of beige colour. So I'm going to apply a little bit of colour to my ground. So the way I'm going to do that is down here where it says Assets. I'm going to right click. I'm going to create, and I'm going to create a new material. Okay. Now you can see that what this does is it brings up all this all these numbers and all these options and things like that. You can name it whatever you like, so I'm going to just call it floor, so that I know that this is going to be for my floor. And I've got an option here of actually being able to change the colour. So I can choose a whole bunch of different colours. So I can choose, I don't know, let's make it green so that it's a bit more like grass. Okay. Now again, you can use RGB codes as well, and also set how opaque the actual layer is. But you can see now that I've got a floor layer, and there are a whole bunch of different things that you can play with there in order to change how your floor looks. And what I'm going to do is I'm going to take this material and I'm going to actually drag it onto the asset. So now I've got this green coloured floor. And if I go back to this material and I decide, do you know what, actually I want to make it blue, you can see that because that material has been applied to that asset, it means now every time I change it, it by default will change within the Unity world as well. So it's not going to be constantly, you don't have to constantly change it if you decide to adjust how, what colour your floor is. I think I'm going to make it slightly brighter actually. So let's do that. Oh dear. Well, that's not gone quite to plan, has it?
It's not too bad. I think I can see well enough.
Let's make it... You could play with this colour wheel for hours. That'll do. There we go. Okay, so we've got our floor. Now, I know this is a bit small, and if you so desire, you can change the scale just here. The scale is what will allow you to actually change the size of your plane. So I'm only going to increase it a tiny amount, but let's just say I decide I want it to be 1.5. Okay, you can see now that by increasing the scale along the X, Y, and Z axis, I've made it marginally thicker, not much, but also slightly wider and slightly longer. Now, what we can do, in order for our character to have a couple of barriers to stop it from falling off, because at the moment, if we were to place a character within this world and move towards the edge of the map, basically the character would just fall off into an abyss and would never be seen again. And we don't really want that, because that's not something that typically happens in games, unless there's some kind of glitch and then you just kind of fall underneath the map, which is never particularly fun, especially if you've got to a really tricky part of the game and then suddenly you're finding that you're falling through the map, and then you're realising that you're going to have to go back around 4 to 5 levels, which is never convenient. So what we're going to do is we're going to try and prevent that from happening in our kind of Unity game by setting up a couple of barriers. So what I'm going to do, I'm going to add in a couple of 3D objects. I'm just going to add in a few cubes. So as you can see here, I have a cube. Again, remember, you can move that around using the arrows. You can see it's here. And what we're going to do is we're going to actually make these cubes sort of be the same length and width as our plane, so that we can kind of add them as barriers. Now, of course, at the moment you can see that it's kind of floating. So we're going to set the Y position to being 0. And now it's kind of gone through the floor, which again isn't ideal. So you can just adjust this so that it's sort of flush against the floor. And what we're going to do, we're going to duplicate this. So I'm going to right click on where it says cube here in my objects list, and I'm going to duplicate it. I'm going to duplicate it for another 3 times, so that I've got 4 cubes in total, 1 for each side. Okay. Now, in fact, actually, what would be more sensible than that? I'm going to just delete these. I'm actually going to adjust the scale of them first, so that I get one side correctly scaled, and then all I have to do with the others is then rotate them to fit on each side. So I'm going to first of all do the left hand side of the plane here. My Y position is currently fine, and we'll just even it out, so it's going to be set to 0.5. But I need to change the X scale and the Z scale so that we have sort of a bit of a wall shape, so that it's long enough. So currently, if we make it 1.5, you can see it doesn't really have the same effect as what scaling the plane did, because the plane was already much larger than the cube when we created it. So if we select this scale tool option in the top here, we can actually just drag out our cube and extend it a little bit so that it actually fits the full length of our plane. Now I've made that a little bit too long, so we're just going to put that there. We're going to bring it back just a smidge. Pop that there. You can see we're still a little bit too long, so we're going to just readjust. It's quite a painstaking task sometimes, but we'll get there. So again, you just have to kind of keep repositioning, and then eventually you'll find that you get it just right. So I would argue that that'll do. We'll just bring
Not
it out
bad.
a little bit. There we go. That'll do. It doesn't matter if it's a little bit over, because at the end of the day, it's all going to join up at some point. That'll do. Okay, so what I'm going to do now is I'm going to actually right-click on my cube. I'm going to duplicate it. There it is. Do that same again. We've got another one there. And then we're going to duplicate that again. Now, at the moment, of course, we can put that one there, which is fine. You can see that it's pretty much even. There we go. But these two are currently just a little bit, well, they're wrong, basically. They're the wrong way around. So we're going to rotate those using that rotate tool that we talked about earlier. So we're just going to spin. This is always slightly tricky. Just going to spin it round. So we can spin it around 90 degrees. And
I can now see why you spent so much time saying, like, explaining how you can change your viewpoints at the beginning.
Yes, yeah, it is a challenge sometimes because all you have to do, yeah, it is just about constantly repositioning yourself so that you can actually see what you're doing. So I am apologising to anybody who is looking at this and going, "Wow, that is a really shoddy job." I will fix it. Don't worry. Okay, that's looking a bit better now. So same with this one, but of course with this one we need to rotate it 90 degrees as well. Much easier to just do it with the rotation value. So again, 90 degrees, we can rotate it, and then we can just drag it into position. So we're just going to hop it sort of, there we go. I would say that that's reasonable. What would you say, Nia? Ooh.
I agree. I think that looks lovely.
Wonderful.
That'll do the job. No
That'll
falling
do
to the
the
abyss.
job. Yeah, look at that. We've got a wonderful cube. Now, I don't like the grey, so I am going to change it a little bit. So I'm going to make another new material. So I'm just going to call this walls, something like that. And I'm going to make them like a bit of a weird kind of brightish colour. So I'm going to apply this material to each one of my 4 walls. So now we've got a bit of a barrier going on, which I think looks pretty reasonable. So we're doing okay, I would say. We've got, I know this is very tiny, but we have got a platform. We've got 4 walls. You can obviously make this as large as you like. You know, I mean, a lot of you probably who are watching have probably played many a video game and are aware of the fact that typically games, you know, they're slightly bigger than this. Tomb Raider, for example, I don't think is this big, at least not when I played it. Various other games, typically much larger than this, but you know, it's a start. So what we're going to do... I was
wondering,
yeah.
You've mentioned video games. Like, what sort of video games can you build using Unity?
That's a very good question, and I'm not too sure of. There are many games. You can build 2D games. You can also build games like this which are 3D. Effectively, there are. I know there are lots of many popular games that have been created in Unity. Because it's such a popular platform, you know, so many different people use Unity on a routine basis.
Yeah.
Because it's just so accessible, you know, to allow you to create games and things. But there are many different types of games that have been made in Unity, and there are lots of different ones out there as well. It's worth a Google, you know, for popular games that have been built in Unity. I can't think of any examples off the top of my head, but there are lots.
I'll have a look, see if I can find something.
Wonderful.
Carry on.
Okay. So we're going to add a little object as well to our plane that's going to be our player. One of the nicest and one of the ways that, again, my lecturer here used, one of the ones that he used in his tutorial, a really nice object that you can use to act as a player character is another 3D object, and it's a capsule. I'm just going to bring the capsule up here. There it is. Now I'm going to rename this capsule to being player, just so that I know that it's my player object. What I'm going to do is I'm going to rest the player sort of on the ground. Don't need to do much with it currently, but what I am going to do is change its color a little bit. So I'm going to make it. I'm going to make a new material. Beautiful. And what I'm going to do is I'm going to make it kind of like a blue color. Let's try that again. There we go. So we'll rename this to be a player. Apply that to my player object. So now we have got our player inside of 4 walls resting on a plane. Now, at the moment, if I hit the play button, so FYI, along the top of the screen here, we've got the play and pause buttons. I'm going to run the play button. Currently, we can see that our game, so the preview for our game is going to appear on the right hand side of the screen here, by the way. I'm pressing all the buttons on my keyboard and nothing is happening. The capsule is basically stuck. Okay. Ooh, that reminds me actually, one important thing to point out as well. Always, always, always make sure that when you are programming in Unity, or when you're making any alterations in Unity, make sure that your game is not running. Okay, always make sure that you are not actually running your game, because like at the moment you can see that my play button is actually blue. Now if you're running a game and you make changes, as far as I remember, when you when you unclick the play button to stop your game, any changes that you've made in the Unity editor to any asset will basically revert to how they were before you clicked the play button. So you need to always make sure that before you move on, you unclick that you stop the game, basically, that you stop it from running. Otherwise, any changes, they just basically won't apply. Okay, now I'm going to quickly adjust my camera position as well, so that we're going to kind of be looking down upon the platform. So I'm going to just do a little bit of camera rotation here. And we're going to just do a bit of a reposition. So that way we can actually see what's kind of going on in our game a little bit. We'll bring it down a smidge and we'll just rotate it back. Sideways, so we'll just go, there we go. Okay, and then what I'm also going to do is just reposition my player, kind of put it, oop, that's the plane, not the player. There we go. We'll kind of move our player to being sort of at the start here. And I'm just looking here, I want to just make sure that we're all facing the correct direction as well. There we are. Okay, so we may have to readjust the camera once we've completed the programming. One thing as well to point out is that if I click on these cube objects and stuff, some of you will notice that along the right of the screen here, I've actually got what's called a box collider, and similarly on my player, I have a capsule collider. This is going to allow us to actually, well, basically what it's going to allow us to do is actually collide with objects and stop us from actually going through them, because at the moment, if we weren't to have a capsule collider or any sort of colliders, it would be possible for us to just glide through objects, which again isn't an ideal thing when you're playing a game. So it is important that you make sure that you have those colliders there turned on. If you do accidentally delete them, you can just go into add component and you can actually just search for them. So we could just say capsule collider, and you can see that it brings it up, and you can just re-add it to your inspector screen here. Okay. Now, before we move on to the next part, always make sure, of course, that you save your work so that you don't lose anything as we go through. And did you manage to find any interesting games that were made in Unity yet, Nia?
I did. So I had a look on Wikipedia, Fount of All Knowledge, and there's
Uh,
a number of games that I sort of recognize. There's Kerbal Space Program. There's at least one Lara Croft game because you were talking about
mm,
Tomb Raider, Elder Scrolls. What else have we got here? Uh, a few Mario World sort of spin-offs have been done,
mhm.
Mario Kart, all sorts of different games, and again, lots of games that I've heard of. I'm not a massive gamer, but there's plenty here that I've heard of as well.
Wonderful. So many a game has been created in Unity over the years, and like I said, it's a very popular platform. There is a lot of documentation available to us. Particularly on the Unity website and things like that. There's so much in the way of documentation stuff, basically, that you can use in order to sort of help you, come to terms with Unity a little bit more. There are also lots and lots of video tutorials out there on how to start a game, build a basic platformer, create some AI within Unity. There are lots and lots of different tutorials out there, lots and lots of different things um, that are out there that you can use. Now, what we're actually going to start doing now is we're going to start the process of actually programming our character so that it can actually move around. Because at the moment, as we've seen, our character is a bit hopeless. It just sort of, well, it's completely lifeless. It doesn't do anything. It's just currently a cylinder, which isn't really a useful tool. So what we're going to do is we're going to do a bit of programming. And the way, okay, so I have got installed on my computer, which again I have a license to because of my kind of university credentials and things like that. I'm using Visual Studio Code 2019, I believe I'm using. I will confirm that imminently. But it is something that is available. Some of you might already have it. Effectively, to do the programming, I am going to use Visual Studio Code as my default editor, um, mainly because it's very easy to use. It uses various kind of, I believe it's called IntelliSense, where it can basically kind of like auto predict how you want to finish a particular line of code, and it will offer suggestions on how to fix it when you have errors. So I'm going to create a new script which I'm going to use for my player character. And the way that I'm going to do that is down in my assets menu again. I'm going to, in fact, yeah, let's do it that way. So I'm going to right click down in the assets menu. I'm going to go to create, and I'm going to create a C# script. Okay. Now the option is also available to, by default, select the player object, go to add component, and new script. Okay. Now the reason that I'm going to do it this way is because sometimes you might create a script and you'll need to add it to an object later. So in order to show you how to do that, I'm just going to create a script which in the first instance isn't going to be tied to anything. So I'm going to go to create C# script. Now it's brought up my little script icon here. I'm going to give it a name, so I'm just going to call it player underscore movement. That's now appeared there, and I'm going to right click on that, double click on that twice. Now I'm aware that you're probably not yet able to see Visual Studio, and that's fine. I'm just going to click over to it now on OBS, so stand by.
I've never actually used C sharp. A very long
Ah,
time ago, I did a little bit of C++ when I was at university, um, but that's all I've had. So yeah, C sharp is going to be something new to me as well.
Wonderful. Okay, so hopefully you can all see. Can you all see the C sharp? I'll just give it a minute to actually, so we can just make sure the windows change. If you could just confirm, Nia.
Yeah, there we go. Yeah,
Excellent.
fantastic.
Okay, so what we've got here is our C sharp. Well, this isn't our C sharp. This is actually Visual Studio Code. Okay, so actually, forgive me, it is not Visual Studio Code, it is just Visual Studio. I do apologise. Visual Studio and Visual Studio Code are two completely different things. This is Visual Studio, just Visual Studio. Now, what you'll notice is that we have got some, by default, it provides us with this start and update method. So these are our methods, okay? We can see that it prompts you with some information about what the start and update methods actually do. And what you can see here is that it says that start is called before the first frame update, and update is called once per frame. Now, many games, particularly if you're on, various high performance machines and things like that, they will run at 60 frames per second. Okay, so what that basically means is that if we're talking about a game that runs at 60 frames per second, that's going to mean that whatever's in this update, since it's called once per frame, if 60 frames are happening per second, then this is going to happen 60 times per second, because it's happening with every frame. Now that's a lot of processing if you think about it in one way.
Mm-hmm.
There's an awful lot of processing power going on there. So if we're running at 60 frames per second, sometimes even more on certain instances and many machines, you'll find that things are running at much faster than 60 frames per second. But generally we're going to go with 60 frames per second as kind of being just like a baseline for what we're going to do. So these are our two methods. This is all part of our class. Okay, so those of you who have been doing some, who have been in my Techno Club on Wednesdays, we've been doing Python object-oriented programming. We've been doing Python text-based adventure game, and what we used there was a bit of object-oriented programming where we created our own classes and we've created our own methods. This is exactly the same process, okay? Just instead of using Python, we're using C sharp. Okay, so what I've got here is my class, which is going to be for my player movement. These are just all my libraries at the top of the screen. So for those of you who are again in my Python Techno Club, those of you who are familiar with it will have noticed that these keywords kind of like using and stuff like that. The using keyword is similar in a way to how we use the from character import character. It's a similar kind of process. These are all of our libraries, I believe they're called, which contain all of the different bits and pieces that we need. We're going to be adding a little bit of code to each one of these methods that's going to make our character actually move around the world. Now, the first thing that we're going to do is actually outside of our methods. I'm going to press enter twice. I'm going to go down to here. And I'm going to add some code that's basically going to state that we're going to be using a character controller today, which is a facility that's available to us in Unity. Now you'll notice that as I start typing that out, Visual Studio starts prompting me with some suggestions as to what I might want. And you can see that it's actually offering me a controller that allows us to easily do movement constrained by collisions without having to deal with a rigid body. A lot of big words there. We're not going to be using rigid bodies today. We're mainly going to be using just a basic character controller with some collisions. And we need to define kind of like an object for this to be assigned to. Unity is suggesting some names for us, so I'm just going to go with controller. And everything in C# has to end pretty much with a semicolon. Any line of code that you write, pretty much, with the exception of a few things that we'll see in a second, got to end in a semicolon, basically so that it knows that that is the end of a line. Okay? Now, what we also need to do before we get into actually programming any methods at this point is we need to actually produce a variable that's going to hold our speed. Okay, now our character obviously needs to move at a certain speed within our world. What we can do is create a variable. So most of you at this point who are familiar with these streams and Technoclubs and things like that will know that a variable is basically a slot of computer memory that can hold a particular value. What we're going to do is you can, if you so desire, create a fixed sort of speed variable that basically means that in order to change it, you would need to actually access your script in order to actually view and amend the speed that your character can move at. What I'm going to do is I'm going to create a public variable, and it's going to be of type float, which means that it's going to be a decimal number. And by typing out public float, what I'm basically doing is I'm saying that this variable is going to be publicly accessible to me within the Unity editor, which means I'll be able to change its value without having to actually go back to my script to make changes. Okay, which makes our life a little bit easier. Now, I've got to give my variable a name, so I'm just going to call it, sped, apparently. I'm just going to call it speed, and I'm going to make it equal to, we're just going to say 10 to start with. 10 is a good kind of baseline speed value. Okay. Now, we've got our speed, we've got our character controller object. When the game actually starts, we need to specify that our character controller actually grabs the character controller component from our player object. We haven't actually assigned the character controller object to our player object just yet, but we'll do that later on. But we need to basically state that our controller, which we've produced up here, is going to be equal to the character controller component of our player object. Sounds a bit confusing, but basically what we're going to do in a moment is we're going to actually assign a character controller, which is that thing that makes our character move, to our character controller object, and every time the game starts, we want our controller object to basically be assigned that component so that we can actually adjust its speed and direction and things like that. So the way that we're going to do that is we're going to say get component, and then I'm going to use some pointy brackets, and I'm going to say that we're going to get the character controller a component of our controller, which is tied to our player, so that we can do stuff with it. End in an opening and closing bracket and a semicolon, for those of you who can't see that. Might just zoom in a touch. There we go. And that's basically all that's going to happen in our on start menu. Now, we can actually, inside of our update, now the reason that we're going to be putting in this next bit of code inside of the update is because we need it to happen basically continuously as the game is running, okay? We need it to be happening constantly, because otherwise, if we were to put our movement code inside of the start method, it's only going to be able to run once. Not ideal, because then we'll basically not be able to move after the first frame. It would just stop. So we want it to be running every single frame. So what we're going to do is we're going to use something called an if statement. Again, a lot of you might already be familiar with what an if statement is, but effectively it is just a way for a computer to make a decision. It's a way of us basically telling our computer that if a certain condition is true, we want it to be able to do something. Okay? So what we're going to do is we're going to say if, and then we're going to have an open set of round brackets, and we're going to say, I'm going to write this code out and then I'll go through it. We're going to say if input dot, oh my goodness, could I have missed any more keys? Get key, and then another set of opening brackets, and we're going to say key code dot. Now, what you can see is that we're being suggested basically every single key that's available on our keyboard, possibly even a joystick, okay? Lots of different options available. Keypad, letter, mouse, basically any single key that you want. We're going to go with W. The reason I'm going to go with W is because I'm going to be using WASD. If you so desire, you can just use the up, down, left and right arrows by just changing what comes after that dot. But I'm just going to use W because, well, I'm not much of a PC gamer, but I have a gaming PC and I am familiar with, you know, I'm more comfortable using WASD, so that's what we're going to go with. I'm going to end that line of code with an open and closing bracket, curly bracket, sorry. And what that's going to do is it's going to place the two opening and closing curly brackets just there. And if I press enter once, what Visual Studio will do is it will understand that I want some code to go between those two brackets. Now, some of you might be noticing the indentation. Very important. Again, very similar to Python. We're going to have this indentation to kind of have this nested approach to our code where things will be placed inside of each other and it's all going to be part of one big thing at the end of the day. It's all going to be part of a class or a single class, but there are going to be sub-methods inside of that class and sub-if statements inside of those methods and loops inside of methods, and basically it all comes together in the end. But what we're going to do is we're going to use another line of code now, which is going to allow our character to basically be able to move through our world. And we're going to be telling our controller here what to do if our W key is pressed, or whatever key that you've chosen on your keyboard to use for movement. So I'm going to say controller. I am constantly, for those of you who are watching who are in the Wednesday Techno Club, will be familiar with the fact that I've had a very busy couple of days and my spelling has gone a little bit out the window, and I am pressing all kinds of keys on the keyboard. So we're going to go with controller dot, and we're going to use something called simple move. Okay, now, and that's going to end in an open and closing curly bracket. Now, open closed rounded bracket, not curly bracket. Now, what we're going to do is we're going to actually have our character move using the Unity vectors. Now, I'm not going to go into too much detail about what a vector is at this time, but just trust me when I say that we're going to need the vector 3, okay? So it's basically going to be the vectors are going to be our position within the Unity world, okay? And what we're going to say is vector 3 dot forward, and we need to multiply that by our speed variable. And again, it's going to end in a semicolon. Now, what we're basically saying here, if I just recap what we've got going on down here with this code, we're saying that if, as the user, I am inputting the W key, or I am pressing the W key on my keyboard, I want my character controller to move my character forwards along the vector 3 position at the speed that I've specified within the Unity editor. It's going to be defaulted to 10 because that's what we've specified up here, but within the Unity editor we can adjust that if we so desire. Okay. Now at the moment, all my character is able to do is move forwards, backwards, left. Is move forwards. We need it. Just move forwards. We need it to move forward, backwards, left, and right. So it's not going to be much of a character if it can't do that. So what I'm going to do is I'm going to cheat a little bit here, and I'm going to highlight all of this, and I'm going to do Control C. Okay. I'm going to go to where my closing curly bracket is. I'm going to press Enter twice, and then I'm going to press Control V on my keyboard. Alternatively, you could just copy and paste. Okay, whatever works for you. Now, at the moment, all of these are set to W, and we don't want that. If you're using the arrow keys, you will need to change each one of these to being up, down. Well, you're going to have up at the top, so you're going to need down, possibly left and right. Okay, I'm going to be changing mine to being for appropriate to WASD, so I'm going to say S, and then A, and then this one is going to become D. Okay, so I've got WAS and D. Now, at the moment, with the S key, which is my backwards key, I could specify one of two things here. I could either specify, I believe, a negative in front of the speed, I think, which will move my character backwards. Or the simplest thing to do is we can just change forward to being back. And what that's going to do basically is it's going to say now that my character is going to move backwards when I press the S key. Now similarly down here I can change my forward here to being left and the D here to being right. And effectively what that's going to do is it's going to say now that with each of these keys, when I press the W key, I'm going to move forward along the vector 3. With the S key, I'm going to move back along the vector 3. With the A key, I'm going to move left along the vector 3. And with the D key, I'm going to move right along the vector 3. And these are all multiplied by my speed, which means that as I move through my world, I'm going to be moving along the speed that I have specified. So, to recap what we've got here, I have got a character controller object that's eventually going to be tied to my character object within Unity, and I've specified a public float, which is a float is a type of variable, and it's basically one that can hold a decimal value. And I have got I've named it speed, and I've just given it a value of 10. And then what we've got down here is we're grabbing that character controller component of our character object, and we are going to tell it what to do if specific keys are pressed on my keyboard. So for me it's the WASD keys, and what we're doing is we're saying that we want our character controller to move. So simple move is one of the built-in kind of methods within Unity that we can use. We want it to move along the vector 3 positions, forward, backwards, left and right, multiplied by our speed, okay, which is going to indicate how quickly our character is going to move. Now it's very important at this point that you save your code, so press Control S on your keyboard or go to File and save assets, player movement.cs, because without doing that, what will effectively happen is the code won't actually be applied to your game. Okay, it won't actually apply the code to your game. Now we're going to hop back over now into Unity again, just like that, and you'll notice now that along the right hand side of my screen here, my code has appeared when I click on my player movement script just down the bottom of the screen here. So all that code is available to me, and I need to add that to my player object. So I'm going to go back to player, and I can basically take my player movement script down here. I'm not going to click on it, I'm just going to hold down left click over the script, and I'm going to drag it and apply it to my player object. Now you'll notice that that speed variable that I've created is now publicly available to us for us to adjust accordingly within the Unity editor, as opposed to us having to go directly into the script and making amendments to it that way, which is a bit more tricky. Okay, well it's not tricky, it's just a bit more of a faff if you're trying to, you know, make quick amendments to things.
And that's because you declared it public.
Public,
right?
absolutely.
Yeah,
so if I won't show it, but if I go back into my code and I was to change this to just being a float speed 10, I'll save my code, and if I hop back into Unity, you'll notice that it's actually now disappeared. And that is because it's no longer public. So it's much easier if you really just keep it as being a public float. You might not want everything to be publicly available, but it's just kind of more convenient sometimes for certain things if it is. Okay, now if I was to run this, it's not actually going to work, as we can see. And you'll notice that as I press the keys, it's giving me an error down the bottom of the screen here, which I can also show you by clicking on console, where we can see that it's telling me that there is no character controller attached to the player game object, but a script is trying to access it. And then it's giving me a reason as to why. So it's or a suggestion for a fix. So it's saying you probably need to add a character controller to the game object player, or your script needs to check if the component is attached before using it. So at the moment, I haven't attached that character controller object to, or component, sorry, to my player. So what I'm going to do is I'm going to go down here to add component, and I'm going to search for character controller. And you can see that as I start typing it out, character controller appears, and I'm going to just click that. Now you'll notice that this gives us a whole bunch of other parameters which we're not going to worry about just yet. Okay? But if I now save my game, run it, and I use WAS and D, as I move around, you can see that I can press W to move forward, D to move right, A to move left, and S to move back. And I can navigate all the way around. And if I bump into a wall, I can't actually go through it and fall off the edge of the map because I have the appropriate code and the colliders in place. Okay. Now, if you were to feel like your character was moving slightly too quickly, remember, stop the game before making an edit, and you can adjust the speed. So I might choose to halve my speed and make it 5. Now, if I click play, you can see that I'm now moving a lot slower, which is perfectly reasonable. But it's up to you what you choose to have as a speed is completely up to you. Okay. So I'm going to stop my game from running. And what we can also do is adjust the direction of light as well, which can be a particularly useful facility. So if we was to rotate the light, you can see that you can actually adjust the way that the shadows are pointing. You can also adjust things like the rotation of the light and things like that as well, which can be quite useful. Again, subject to the type of game that you're creating, you have the ability to change that direction of light. So, I've now got my game, and I've got my basic movement. I can move all around. What you choose to now do with your game is up to you. Okay, now obviously you could make this a lot bigger than this if you wanted to. You could make it an infinite sort of size. It is important to kind of keep in mind, of course, that it is a lot of this could be subject to how powerful your computer is. Some people might have a bit more powerful machine than others, which means that in certain circumstances Unity might run really, really well, but for other people Unity might run really, really slowly. It's just one of those things that varies from machine to machine. I created a game in Unity for university, and by the time I'd finished creating the game in Unity, it was very, very slow to open because I had so much AI and stuff added into it. So, it is subject to that kind of thing. But remember, it's always important to keep saving your games consistently. Now, you could, for example, continue to add in a few more objects. So I might choose to add in some cubes, just some random cubes, to act as barriers or something, some kind of obstacles for you to avoid. You can also just press Control D when you've highlighted a particular object in the objects menu, and that will also duplicate it so that you can have that easier than sometimes doing right click, duplicate, and things like that. So we could place some kind of obstacles for us to navigate around. Might want to make one a little bit bigger. Do kind of some sort of obstacles. We could do something like that. Could build like a maze, something similar. This is the world's worst maze.
You got to start somewhere.
You do. There we go. But if we now run this, see that, I can't get through, so I've got to go around. Now, I know this game isn't doing much currently. It is just, this today has just been a bit of a basic introduction. But it's a start. You've got the basic movement, you've got some colliders, you can't get around certain spaces, you've got your platform, you've got your environment all created. So this is really a basic kind of introduction to the basics of Unity. And you can add as many different things as you like. Again, one thing that you can do in Unity, and there are many tutorials out there, is you could add some AI. So you could have your characters, you could have some AI characters that are, running around, that are moving around in your world. You could have them seek you or sort of flee away from you. There are a number of different things that you can do within Unity. It's a very kind of popular platform for that sort of thing. And it's well worth, like I said, taking a look at that documentation, having a look to see what sort of things are available online for Unity, having a look at a few tutorials if you're interested in doing more. We're hoping, well, at some point we might bring Unity back again. We might see if we can do a few kind of basic AI tutorials in Unity. Again, that will be subject to how much, how popular this video is and things like that, of course. But we might, hopefully, if you're all interested in Unity and things like that, we could bring it back. And we could start looking at doing maybe some basic AI or something like that, in order to add a bit more kind of entertainment to the game world, so to speak. Because currently, I mean, I accept it is not the most interesting, but we've done the basic programming.
Yeah, and you say it's not interesting, but I mean, fundamentally, like that bit of code, even though I've never written any C#, I don't know anything about Visual Studio, none of it is scary. Like the code sort of makes sense. It's quite easy to read so far. Anyway, I know you've only got, you can only do 4 little things, but so far it doesn't seem,
too overwhelming or anything like that. Really,
exactly.
Does it? Yeah.
And I think being able to introduce some AI relatively easily, I'll say, well, having never done it before, I think that sounds very exciting to be able to do that.
It does. It is very. It is really exciting when you start to see your own kind of capsules just running around on a screen. It is very amusing, actually, and there's a lot that you can do with the AI within Unity. But we are starting to actually draw to a close now with with today's session. So what I will say is, once again, thank you all very much indeed for taking part in today's Technolive session. Like I said, next week, for those of you who are part of the Techno Clubs, there are no Techno Clubs next week as it is half term, but we have, I believe, still got a Technolive session. I apologise if one doesn't come up, but I'm almost certain that we do have a Technolive session scheduled for next week, so that will be on Thursday. If there is no Technolive session, then they will resume after the half term. Okay, but there will be, I believe we have got a Technolive session scheduled. But that's all from us today. So again, thank you all very much for taking part. Thank you, Nia, for joining me again this week.
No worries.
And
thanks very much for having me.
No problem. And next week, like I said, if we are back next week, it will be Jack is back once again. So that will be all from us for today, I think. So again, thank you, Nia. Thank you all so much for taking part, and we will see you very soon. Thank you, and have a good evening.